So now, where can I find climate simulations? Maybe it's the most important part for you if you want to make some kind of climate change studies and use climate change scenarios where you can find climate simulations. In fact, you can have a lot of information, very good information in the interactive atlas from the IPCC. You have here the link of the IPCC, the last IPCC report, which is dedicated to regional information, to regional um, data, and you can look at possible climate futures. Well, you can look at different plots in the future at +2 degrees, +3 degrees, +4 degrees in the different regions of interest. So you can make a lot of interesting maps. You can download also some data in different countries. And it's really interesting to see. You have also summaries per countries to look at how the climate could change in your region of interest. Then there are also some other platforms that exist. You have Climate for Impact that have been developed by the European project Easiness, where you can have semi-6 or semi-5 data, which are the different intercomparison exercises that are used for IPCC report. You can extract temperature, precipitation, humidity, different kind of variables. You can also have an interface to make some Python computing if you are aware about Python, if you are used to use computing languages like Python, you can use this interface, which is very complex but very powerful. You have also the Copernicus access, which is also very interesting. It has been done by the European effort, which is called Copernicus on climate services. And you can also select a different kind of data, different climate models, different variables, different time periods, and different region of interest, and export these files into mixed files, which are a format widely used by the climate community in the world. And then it's what we have done at IRB, which is in fact we have tried to do that much more on a much more simpler way than the Copernicus platform, in order to be complementary to this platform. And we have tried to make a kind of user-friendly interface to access easily to climate projections. So I'm going to present the different features of the platform and how we have first designed this platform. In fact, what we have done at the beginning, we have made interviews of different actors that were researchers from the south, managers or of companies. In total, 30 participants to workshops, trying to know what are their needs in terms of climate information, what are their needs in terms of implementation of climate information, in terms of what are their resources, in terms, for instance, the network they use, what they could, what they would see in terms of interface, in terms of needs for climate information. So we have done that with people, with researchers from Africa, from South America, from Southeast Asia, and try to collect their all they wanted to see in a platform before designing anything. So we ask them to draw with pen just what they want to see in terms of interface, in terms of the visual of the platform, the functionality they wanted to see in the platform, in order to have a participatory way to design the platform, not to bring something that coming from nowhere, but coming from what they wanted to have. We have here an example of what they told us. They wanted to have a disk space, to have something that could be used with a not so good internet connection. They wanted to have something online that could be easy to use, that could be easily to understand. They wanted to be autonomous to make operation. So that's what we have tried to do. And we have then highlighted different key success factors before designing anything. So we wanted to have a platform that could centralize and facilitate access to data, that could be used with that could do a search very easily, like mapping with listing different location, that could provide something at different temporal resolution, and that could perform also calculation and create visualization that could be exported into different formats, and especially a format that are not expert format. So we do not want to address the climate experts, maybe like the Copernicus platform do, but we wanted to communicate with the different communities, like working on impacts, like biology, like agronomy, like hydrology, who are not experts on the use of climate information. So then after we started to develop the platform from this information. So we have contracted a company which is called ClimatSuds, and they were in charge of climate data collection, of formatting the web page, of also designing user testing, trials, bug fixes, and then we have started with the platform. And in the platform, we have different available data sets. So I'm going to show you the platform in the next minutes. But what we have in terms of climate data, you have 6 climate models and data. So these are the climate data in the last IPCC and the latest IPCC report. So it means that it's the most recent state-of-the-art climate data you have in the platform. This data is corrected of biases. It means that we have tried to remove the biases in terms of rainfall, of temperature, so that they are very close to the observation for the historical part. And we have 22 models at the daily resolution, at 0.25 degrees of resolution, of horizontal resolution. And the different variables are available: precipitation, minimum and maximum temperatures. We have also sectoral impact data that come from impact models with different emission scenarios. You have projection of crop yields, you have projection of vegetation, of hydrology, of burnt areas. So we have some impact data that are coming from impact models. But you need to know that, as I told you previously, there are a lot of uncertainty in this impact simulation, in the also climate simulation. So it's not reality, just projections based on the latest state of the art of the climate community. We have also climate indices that have been computed based on the expert team of climate change detection and indices of the World Meteorological Organization, which are the most known climate indices. We have extreme indices like the duration of heat waves, like very hot days. You have maximum wet period, maximum dry period. You have extreme rainfall, so that you can see how the climate is going to change, not only the mean climate, but also the extreme of climate. So these indices are very useful because sometimes you can see that the mean rainfall can change very slowly, but the extreme of rainfall, such as very heavy rainfall events, such as drought, could change much more rapidly than the mean state of climate. So the features of the platform, when you connect to the platform, you have the main interface, which show the title of the platform, what we are going to do with the platform. Then you need to create an account. So I hope you have done that before the training. I'm sure you have done that. So we have tried to restrict the access because of several reasons. First, we didn't want to be flooded by the number of connection at the same time, because it is hosted in not so big server, so we did not want to be flooded by the number of connections. We also wanted that the user could save his search, could store his data, and so that we need an account. And with this account, you can then have access to your different searches, to the different data you have downloaded previously. So here's an example of my own account where I downloaded data from Lac Chad with different indices of temperature, with maximum temperature. And you can see that I'm almost, I have a lot of data, and you can see my monthly use of the platform. So it's very important because I can close my internet navigator and then go back to what I've searched and get my data just a few days after, or a few months after. So it's always saved. So the basic interface, it's the data room where you can get the data. You access to the main tool of the platform to extract climate data. There are 3 types of requests. You can select a point on map. So you are interested in one location, in one point, in a city, for instance, in the city of Dakar, in the city of Abidjan, and you want to know what could be the climate change scenario in this location. You can also select a country on map. You are interested in Nigeria, you are interested in Ghana. You can select this country, and you will have the data averaged in this country. And you can also draw a polygon on a map, and a free polygon, which could be, for instance, a lake, which could be a plot, which could be a field where you are working, or a district, or something like that, a specific region. And then you will also have the average of climate change data over this polygon. So here's an example of selecting a point, or selecting a country. Here it's the Congo, or selecting a polygon. You can see here that I could draw a polygon over Cameroon, and over Nigeria, and over Chad. Then after, when you have selected the zone, you can access to different types of data available. So you have different type of data. You have easy impact indices. that are the impact data. You have temperature and precipitation indices that are annual data and daily variables. So climate impact indices are the one coming from impact models. So you have different projection of crop yield, of wheat, of rice, of maize. You have also vegetation indices that are leaf area index. You have highest runoff coming from an hydrological model. You have also highest wet bulb global temperature, which is a heat wave index. And you have also burnt area, which is coming from a model simulating the effect of drought, the effect of high temperature on fires. Then you have also annual climate indices that are different extreme indices. So these are annual indices. So one value per year. You have the maximum 5 days precipitation, the total wet days precipitation. You have the number of EV precipitation days, maximum consecutive wet days, maximum consecutive dry days, which could be used for drought. So a lot of indices that could be used to look at how could be the future climate in the region. And then you have also daily values, so 1 values per day of minimum temperature, which is the night temperature, maximum temperature, which is the day temperature, and also the mean temperature, and also the daily rainfall. Then when you have selected the data you wanted, so your climate indices, you have different scenarios. So these scenarios are emission scenarios, greenhouse gases emission scenarios. You have different kind of scenarios. So 2.6 is the most optimistic scenario, the scenario where we could reduce drastically greenhouse gas emissions. And 4.5 is the median scenario. It's kind of the scenario we are following today, the pathway we are following today in terms of emissions. And then after you have extreme scenarios, especially the 8.5 scenario, which is the scenarios where the greenhouse gases emission is the highest. Then when you have selected your scenarios, you can save your data in a project. Each extractant can be selected, and so that you can retrieve your data later in your personal account. Then after you have, it's not completely interactive because you will have to wait for a couple of seconds, a couple of minutes sometimes, so that the server can get you the data, can provide you the data. So you have a progress bar during the extraction, and the good news is that you can close your navigator, and you will have an email which is going to be sent when the extraction is going to be completed. And in the email, you will have the link to get the data. You will just have to click on the link, and you will be able to extract the data very easily. So we'll have the extraction when you will have the email, or when the bar will be completed. You will have the data with here it's the figure of the mean temperature I've extracted in this point. So you have the location of the point I've extracted. You have the different scenarios. So SSP 1.2.6, which is the lower scenario, lower emission scenarios, the SSP 8.5, which is the highest emission scenarios. And you can see in this figure the evolution of temperature with the historical simulation of the model. So it's the average of all models, and you have an envelope which is based on the uncertainty coming from the different climate models we have here. It's an average of kind of 20 climate models, 20 different climate models. So you can see that in black, the models, the ensemble models is simulating an increase of temperature, and you can see that then after the temperature is keep on increasing, especially with the red scenarios, which is the highest emission scenarios. Then you can export the data. You can export it in CSV, which is the format that allow you to be used in Excel, for instance. You can also download it in NetCDF, which is a format widely used by the climate community. You can export also the plot and then use it for a presentation, for PowerPoint presentation, as I've done today. And here it's an example of how you could export in a CSV. So you have here the export of the data. You have several columns. You can see that you have a column which is called East, which is historical data from 1950 to the 2005, I think. So historical for each column is a climate model. So you can see that there is a lot of climate models, more than 15. And then after the historical period, you can also have the future period. If you have selected a future period, if you have selected scenarios of the future, you will also have scenarios of the future. So what is important here to see is the name of the different climate model. You can see that you will have completely different values from one model to another. And for your depending on what you want to do with this with data, you can select one model. You can select 2 or 3 different models. You can average different climate models. It's up to you to use this data. You can also export the data in NetCDF. You will have here the description of the NetCDF file. Here it's for an example for the temperature, the surface temperature, CMIP6. And you have the dimension. It's always a vector, so it's not a big file of data. But you can have different variables in the same file. You can have different climate models in the same file as well. So the next steps now are for us is to develop the training contents. So we don't have a lot of interactive tool to describe our platform. We don't have a lot of description of the data so far. So it's still an ongoing work. We are trying to work on it. We are trying to do that online, like the training I'm doing today, but also trying to organize summer schools with climate experts and using the platform, and also using climate impact based on the output of the platform. We are also keep on working to add some new climate simulation with higher resolution. We are also trying to increase the bandwidth speed of the platform, to also to create a dedicated access for commercial users, which are not allowed today to use the platform, and also to obtain some feedbacks from users like you to increase the performance and the usability of the platform. So now I can stop now, and maybe if you have some question of what I've presented you up to now, before we start to manipulate the platform, I will be very happy to answer your question.